Perfect. Good morning, everyone. I hope you can see me and hear me well. Welcome back to this new and last webinar from our energy data and modeling program here from the IEA. Today we will have, as I said, the last theoretical lecture, and then last week we will have a final lecture, final webinar in which we will just wrap up the overall program and ask you some really small questions just to have feedback on how the program went, and which will also help us in order to design the next phase of this program. So today we have with us Thierry Oudou, which will lead the entire webinar, and the topic is solid biofuels estimation model. So I will just remind you that if you have questions, you can write them in the Q&A box, or you can also raise your hand, and then I will give you the possibility to unmute yourselves and turn on your video and directly ask the question to Thierry. So I leave the floor to Thierry in order for him to introduce himself, and for any need, I'm here connected. Thank you, and the floor is yours, Thierry.
Thank you. Good morning, everyone, or good afternoon, depending where you are. So good morning, Dana, for this introduction. So I am Thierry Oudou. I'm an associated consultant with the IEA, focusing on the solid biofuel estimation for Africa. So the presentation of today will be focusing on the presenting the model that we have been developing to improve the solid biofuel estimation around the continent, and also to go through the model and have some time on it and how to use it, and also to play with the exercise we have sent you sometimes ago. So yeah, let's get started. So we all know these figures today, and Africa represents about 50% of the global solid biofuel production, and mainly it's being used for cooking process, and mainly our women are part of these processes, and we know all the environmental and health concerns that's related to it. And if you can see on the right-hand side of my slide, if you look at the share of the biomass onto the primary energy supply is more than 50% in most of the countries of this project, and in Kenya is about 65%. So this shows how important this was part of our total energy mix. And it's very important for us to have a look on this and know to estimate this demand, on which proper policies and action can be taken in order to be on track regarding the different agenda. And we used to classify them mainly into three categories. We have the firewood, the charcoal, and agricultural residue. On the other hand, there is a growing demand, and the population also is growing. And definitely what we realize in all scenarios that the solid biofuel consumption will still grow in the coming years. And the main concern is that the traditional use of this is stunting our population and so on. So therefore, knowing how this demand will grow in the future or how it's being consumed is very important to take a proper action over the continent. So that's required for agency like the IEA and other international organizations to collect data about this in order to track the different progress the country have made in terms of the national determined contribution regarding the Paris Agreement, and also how the country are doing in terms of achieving sustainable development goals. And ideally, in the IEA, they collect the official data that countries send them, and based on which they inform the energy balance at the end of the day. But what most of this, what we realize with this data is that there is lack of recent data, and also consistency over the years. And from one country to another, you realize there's a difference in terms of the methodology that country have been using, and therefore different organizations this has resulted with different using some estimation methods based on macroeconomic trends such as GDP and so on. This, which might not be the reality on the ground, and might create a lot of biases. That's why it's truly important for us to really see how we can improve that by developing a model that can help to bridge this gap and more or less not replacing what is been doing on ground, but also try to reduce as much as possible biases in the data. And therefore, if we reduce the biases, we are sure that the result also is less bias as well. So it is in light of this that the IEA with the European Union have co-funded this program to improve the data collection. They report information about various events such as biofuel in the 10 certain countries, including Kenya. So one of the activities is to provide estimates, estimation, and verification to improve the energy balance within the selected countries, and also to make available a user-friendly model that we will be presenting today that can help into solely biofuel estimation for the different fuel type emission, such as charcoal, firewood, and agricultural resilience. And lastly, is to foster discussion among these countries and around solid biofuel, and also promote experience sharing, knowledge sharing, and through the different capacity building that the IEA has been having, especially what we are having today in the series of webinars we started some time ago. So the main, as I said, the main topic today is to present you this model that we have developed as part of the helping into the estimation of this consumption. So given the context that I presented earlier, we try to use the available data sets. Despite all these challenges, we try to use looking at what are the different database and share data that we have now that we can use to make up a model that can try to provide a more or less data estimate that can feed into the global energy balances and our different estimations. So we make use of different database, in particular from the World Health Organization, the World Bank indicators. We have also the global SDGs indicators, and also data coming from the national statistics, and also already data that is available on the IEA project. So it's worth noting that the model can go beyond that, and if you have granular data, and granular data will improve the precision of the model and how far we can know about the consumption, and in particular, knowing the number of households that use it, for instance, improve cooking stoves, or the efficiency of each type of cooking stove that has been used in the field will improve the model calculation. And definitely knowing these kind of metrics, adding to what the model is doing, will provide more granular information, more detailed information, on which proper decisions can be taken, and so on. And these are the limits of the kind of data we can get over the continent. And this is also an occasion to put light on this kind of information that might be interested for us and for the countries to be able to improve our estimation. And also knowing how the fuel wood is being stored, the water content, the selection road, how the way is being used, because not only the complete food, sorry, that can be used for cooking processes. Some have been used for lighting, some have been used for also construction and so on. So knowing all the value chains, all the processes, it's helps to improve the estimation and everything. So here we present the conceptual framework of the model we have built. So yeah, we have here a pre-analysis assessment that we did, and this pre-analysis informed an input model into the model. So for the input model, we have different variables, including socio-economical, technical, and some system-based informations. And we have also a development model where the users can play with, can put some general settings, initialize some assumptions, and also play with scenarios. So all this information feeds into the model. And at the end, on the right-hand side, the model can generate an estimate of the energy consumption per end uses, such as cooking and lighting and other process, and also for fuel type for charcoal, firewood, and agricultural uses, and provide some estimate about the emissions that can be as related to the use of this different fuel. So here I'm presenting a little bit where we start and how we get into having a small model or small number of variables to be used in the model. And I was saying earlier, we had at the beginning huge amount of variables and data sets coming from the different database that I have talked about earlier. And when you have a huge kind of data set like that, first of all, the main challenge is try to reduce the dimensionality, like try to reduce the number of variables and take the one that are sensible or really can explain the energy consumption on the ground. So we did some dimensional reduction processes by using feature selection method. And then we look at, and we come out with 14 variables that explain more or less how we consume firewood or charcoal at residential level in urban or rural areas. So later on, we look at what are the set of these, among these 14 variables, what are the set of variables that will be more relevant for particular fuel type. Is this charcoal in urban, is this charcoal in rural areas, and what are set of variables that can explain at each level the consumption. And then later we do, as we have various variables, definitely we do a multi-regression analysis around it to be able to estimate, to provide an estimate of the given mass consumption per type. So the model, let's say we have four internal models. One that will generate the consumption for charcoal for charcoal in rural areas, charcoal for urban areas, firewood in urban and rural as well. And at the end, we provide all this together in order to provide a national estimate of the consumption. Of course, to do that, you need to calibrate the model onto existing data and also rely on other countries' data. So we use several countries as references. We use countries like Angola, South Africa, Senegal, Botswana, Morocco, and so we analyze them. We analyze the energy consumption, and we try to see if the consumption is the consumption, the unit mass per household is within the standard of West Africa. So we did also a general study about the continent, looking at what is the average consumption for each quarter. Then we try to look at which countries provide an estimate that are within the standard, or within acceptable range. And from there, we take this country as a reference, and then we calibrate the model on it, and then we provide estimate for the for the next year. So on the left-hand side, you have the different input level and the development level that I explained earlier, with some variable as input and some other settings as input to the model. We have all these feature selection regression analysis, but in the output, we have the consumption at the household level for the different settings and urban rural areas. And one thing that I didn't talk about since is about the model can be able to provide feature estimation from 2015 to 2050, and then the user can also play with this kind of protection to implement or to analyze policy decision. For instance, if there is a particular decision saying that, for instance, for example, that we are reducing charcoal by 50%, the model can help you to do that, and then you can see how this could be in terms of consumption and try to take it from there. So so here is a detailed program. We are providing information on the different variables that we have used. And on the development module, for instance, we use some assumption on the agricultural residues. So the agricultural residues, for instance, a share of the total consumption for firewood and charcoal. So these are, for instance, things that if we get more granular information, instead of using percentage, we could have used a more precise value for that in our model. And then net tariff value, the share of also each fuel type as part of the total consumption. And we use for the emission scenario, I said we use the IPCC emission factors for that. Yeah. So when we have the specific consumption, so at the end of the model, what we have really is the unit mass consumption, so in terms kilogram or whatever. And now to have it at a global level, at the national level, we populate this using the number of households for the particular year of estimation. So when the share of household and everything in rural or urban areas, we can now populate the unit mass consumption that we estimate to the entire populations. And then this provides us an estimate for the entire country. So we also know that this model is not providing, is not a optimistic a genius solution, but also have some limitations. As I have started saying, we have the agricultural waste that is also used as part of fuel for cooking purposes and other purposes for lighting as well. What is for us for now, we did not yet capture how to represent this into the model. So what we did is to take some percentage of charcoal, of wood to account for the agricultural waste. So it might introduce some biases into the model. So these are some limitations. Also, is time series dependency, because we have to calibrate the model in a certain number of years where we are sure that we have reliable data. And preferably, it is good to have long historical data to calibrate the model, but because of the data constraint and limitation we have, we concentrate ourselves on the amount of data that we have available. And also, as we selected some contrast references for calibrating the model, it's also depends on the input data and what we get from the different database as well, with critical process automation. So it's also important to highlight that there are some countries that share a lot in terms of the consumption of fuel together. So it might be very difficult to divide or to say separately what is the production, what is the consumption. And this is also one aspect that we may capture into the model that we are trying to improve it daily and daily basis so that it's more or less closer to the reality. Yeah. So I don't know, the link, there is some questions since I cannot see.
No, for the moment, there are no questions.
So if there are questions, please do not hesitate to put it on the chat. I can respond accordingly.
Yes.
So yeah, this is the end for the presentation, more about the whole idea about the model. So if there is no question, maybe I will first of all go through the model, shows how it works, present the different things, and then maybe from there we can have some questions and see how to go through the different exercises we provided in the document. Yeah. Okay, so let me start sharing. Okay, can you see my Excel?
Yes, yes.
Okay, good. So when we open, so we develop this in Excel, Microsoft Excel, to, as most of the stakeholders friendly with Excel. So we develop this model in Excel using the, but with some program design in Visual Basic, so the internal programming language in Excel. But most of the things are available to everyone that can modify and adjust it. And we try to make it as easy as possible so that the user can get through easily and then make it adapt it to his interest. So when you open the Excel file, you land directly on this page where we provide like a kind of control board and with some button that can direct you to different sheets of the model. So we have the introductions. So the introduction come back on the what the project is all about, providing a short understanding of the methodology, but the concept note is there to and provide more detailed information about the different tools, methodology, algorithm we use to come out with the result, and also the data and the features and so on. So now I can go back and yeah, here we have the global demographic data set we use. I know that for each country we have the national statistic and each country provides an estimate of the population. So, but for instance, we use the urbanization cluster of the United Nations report of 2018 that provides an estimate of the population from the year 90 to 2050. So this is the opening for the user to be modified. So if I look at Kenya here, so this is a value that has to be multiplied by 1,000 to reflect value in million order. So you can modify the populations and growth here and everything, so that this can be reflected into the estimation element. So on top you have the total populations, and then you have the population for urban areas. So you can also play with it here. So for the rural areas, the model calculated directly knowing the difference between the population, the total population, and the urban area. So let me go back. So we have the whole database of strategies, different data sets as a part of it for different countries, and yeah. And this is going to be so in the presentation, I said that we have two parts. We have the input module and have the development module. And the development module rely on also on some estimate, on some assumption that we take. And as I said, for residual, we took some percentage, as you can see here. For the net calculated value for each type of well, we use some estimate here, we use some assumption here. But so the user can also adapt this depending on the context of the country. If, for instance, there is a study that has shown that the net calorific or water content of this is within a particular percentage, and knowing the particular water, the percentage of water content in a particular soil, we can derive the net calorific value. So if there is any recent study that's showing a different value from what is developed here, the result can be updated, and then this will play into the estimation. Here you just done some estimates about some constant use for the different units that the model will provide the output. The different emission factors that the model uses are also developed here in the different sources. We hide some of there are some other variables that are hidden here to avoid users to modify the mistake basically. So we just hide them there, but this can still user can still open it in the C. And but this shouldn't be modified because the model is a constant that the model used to calibrate on. That's why we hide them as well. So we have here also some percentage of share, the share of each type of end release as on the total consumption of cooking, lighting, and so we provide the source where you get all this information and then the different percentage. So the model also uses some of this information to estimate how from the total consumption which amount is goes for cooking, for lighting as well. The more we have detailed information about the cooking processes, about lighting processes, the more the model can go in deeper to provide a more precise information, a more precise estimation. As I was saying, for instance, if you know the technology efficiency, the cooking stove efficiency, it helps you to, for instance, knowing exactly the consumption. So it can also reduce overestimation into the model as well. So as you can see, the database, the whole database is quite huge. So it's quite not easy to go through everything like that. So we try to provide the dashboard which help you to go through some specific indicators of the populations. You have the GDP, You have the export of food and services frequency of GDP. You have the energy intensity and the others like ATCSS as well. You can play with there is a time slicer. There is a time slicer at the bottom that you can use to see how the different variables evolve over the years or for a particular year. And then you can select various countries and so on for depending on the purpose of analysis and so on. So the idea with this dashboard is to go through the model is to facilitate the user's ability to go through the database and to get access to particular information of interest. Yeah, so we have some notes about the different updates that has been done on the model, and we continue providing update as we get some input and also feedback from you. So also one of the expectation from this meeting as well is also to have feedback from you, and also how we can also improve this model to be suitable for you, and that can help you in your daily work and what you are doing on the control level. So here we provide on the reference sheet, we provide link with the most of the variable that we use into the model, and then we can also check and also go through it and to see if, for instance, this a particular data that we use for a particular country is reasonable enough and everything. So by doing that, we want also the user also to cross-check with us as well if everything represent everything that we use as input capture the reality of the ground, and you are more in a good position to tell them that. So with this control board, I can navigate through the different sheets and knowing the data, what are data have been used for my country, and I can modify or update it. So there is a button here to get started. There is get started. And when you come on this complete sheet, you have the possibility to select among the country of interest that you want to model. For now, we make it available only for the 10 countries, but we are working to extend it to all African countries so that it's more global. You can also change the units that's available here as well. So let's see for this, if I go for Kenya. So what the model did is that when we select the country of interest, it automatically generates the estimate. So based on the information in the different parameters that we have here, the demographic data set, the database, the whole database, and also a subset of the database that is available here. The model computes the historical, provide an historical estimation from 2000 to 2015. So it's providing an estimate of that to up to 2015 based on the different settings and the data that you have already in the model. And you can see how this is evolved over the years. So you have for charcoal, you have for firewood, and the share of agriculture in the whole consumptions. And then for end users as well, you have the share of each type of end use, such as cooking or fitting, lighting, in the whole consumption phase. So it's showing the share and things. And then from there, you can now do the prediction analysis. Now, we are now working to extend this to 2019. Is why we stop at 2015 because most of the model, most of the variable that we are using are complete up to 2015. So now that we got recent information, we are extending to 2019 or 2020, so that we have an historical estimate up to this year. So we have a projection analysis. On the projection analysis, the user can play with the different variable here. The I think 11, 14 variable that I mentioned in the presentations, and knowing that how this variable will evolve over the years to up to 2050, the user can put some different value, and the model will calibrate onto that to provide an estimate about the solid consumption for up to 2050. And the idea behind this is that by giving this count to the users, it can play with the different trends and then try to see how if these parameters change, how this could affect the consumption at the end of the day. So it's providing more or less a count for position analysis and scenario analysis. So if I leave it like that and I run the projections, then we should take some time. And then after that, it shows you how the consumption will evolve for 2015 to 2050. So you have for different fuel types how this evolve as well. Another interesting thing that the user can also play with is that you can compare maybe from this for the same country two scenarios. So for instance, I can take Kenya and project up to 2050 and set Kenya again, and then modify some of the scenario I have here, and then try to compare this scenario to the improved scenario now, and then see whether if I change the trend of this variable, how this could be perceived into the consumption at the end of the day. So let's see if I want to compare, for instance, and another option is that instead of comparing two countries, comparing the same country, I can compare the country with another, the first country with another country, and then see how this goes. So that is the main use of the comparative analysis. So it takes some time to run and everything. And after that, it provides you with an estimate of the consumption for instance, here we have on top you have Kenya, so below we have the Ethiopia as well. So it's try to provide you an estimate based on the different settings that we have here, so that you can compare how your particular country is doing with another country and so on. But we are trying to extend, for now, this comparative analysis can work only for the 10 countries that we have as part of the project, but we are not trying to extend it to more countries, and we are working on to that in order to calibrate it well, so that it capture the ongoing trends. And after all this analysis, we provide the opportunity for the user to generate a report from it. So based on the different different modifications and user preferences, we provide a short report that can be used to generate, that can be used for different communication purposes. So you can have here the historical consumptions. You have the historical consumption for per images. So we have cocaine, hitting, lighting. So we have the trends and estimates for the consumption up to 2050 for the position. And you have also emissions over the years. So you can see that it's highly diminished the CO2 as well. And that goes on. So we just select subset of figures that we put here to generate the report. And then at the end, you can print it. And then when you print it, you can use the PDF for various communication purposes and presentation. And so then when you end with this, you can go back to the model as well. You can, if you want to see in detail what are the data behind the emission graph, if you want to see data behind the emission graph, you just come on to emission and health sheet below here. Then you can see the different emissions are from 2000 to 2050. for the different NGs and the everything that is typed and so. So you can see that in if the user have a particular interest into doing some exercise or particular purpose in using it. So the usually elaborate program exercises, and then there is from different purposes as well. Yeah, I think yeah, I'll go through everything more or less, and yeah, so I will stop there for now. So this is quite a short overview about what can be done with the model for now. And yeah, I'm open for your questions and provide answers. Thank you. Darling, are you there?
Yes, yes. So there are no questions. Sorry.
Question for now. Okay. So maybe I should go to the exercise. Can you see the exercise file?
No, right now we are still seeing the Excel file.
Okay.
Now it's the Word file. Yeah.
Yeah, good. So what we try to do here is that we provide some friends to helping you to go through the model easily. So with some few questions and how you can do it in the model. So we have how to simulate the buffer simulation for the period. I have already showed that we get started. From the bottom, we get started, you select your function of influence, and automatically you have that generated. So how to calibrate historical estimation based on set of assumptions. As I said, the assumptions are available on the default parameters sheet. So on the default parameter sheet, you have a different, we make available some of the variables that the user can modify to know. So we have the share of residual. We have also the conversion efficiency, like the net output value. We have the emission factor that can be modified. We have also the share of end user that also be modified. And when the user modifies these variables, it directly dynamically change the estimation that is provided in the compute sheet. The compute sheet is more or less where everything is happening. The estimations, the calculations, and all the calculations. So whatever we do in the demographic sheet, in the database or in the default parameters, it automatically take into account in the compute sheet. So we suggest to change some of these variables, some of this value. So as soon as you are updating them, it's automatically translated into the how the models compute the result. And we show you more or less how to get into the results and use some fancy things. And how to estimate the future consumption. I already show you a little bit how to do that without going into detail. But we can play, we provided some for the different variables, some scenario. You have the stated policy scenario step of the IEA. You have the sustainable development pathway scenario as well. And then there's yes, so the user can also play with this or use a business and user scenario as well and see how this will evolve over the years. So based on that, the user can run the projections, and as we run the projections, we can get an estimate to 2050. You know, so this more or less what the exercise is all about. We know that it's difficult if we go through and you see the different explanation provided. You'll be able to go about the model. Yeah. So, I don't know if there's any specific question about the exercise. If you do you have time to go through it? And if so, do you have any issue? You have any issue about using it, and please do not hesitate to give us your comments and suggestions. Thank you.
Yeah, for the moment, I don't see any question. I remind the participants that if they have questions, they can write in the Q&A box or also raise their hand so that I can give them the floor. Thierry, you have a question in the Q&A box. I don't know if you can see it, but Dr. Cheng is asking if the model assume all biomass have same calorific value.
What we did is not, yeah, we can see all biomass, not all biomass, but biomass per type. So what we did is that we say, okay, if we take all firewood, we consider that they have the same net calorific value. Of course, we are aware that it's different from one wood to another, but this is the level of granularity that we have now. We don't have enough data that shows that, for instance, for the total firewood consumption, we have this coming from these trees, this coming from these trees, and in terms of water content, this is the level. But what we try to do is to take an average value. So for each, to respond to the question shortly, is we consider for each fuel type that the net calorific value is the same. So if for firewood, we have the same value for charcoal and so on. But what I guess that can be done in addition to it is to, when we have more detailed data about each kind of fuel, that each kind of wood that is the most useful. So we look at the different material and we take a weighted value about the weighted average that we can put over here for the estimate. Yeah. I don't know if that responds to the question of
yeah, he has an additional question actually, which is related to that. So is there an option in the model for differentiating different types of biomaterial like ethanol, charcoal, firewood, briquettes, etc.?
Okay, now we differentiate, the differentiation is happening for charcoal and firewood. Briquettes and etc. Briquettes are arranged under agricultural residues. All other materials that are made from wood and with agriculture, we put all of them in agricultural residues. So agricultural residues include as well briquettes and processes, the output of the process of wood and so on. Yeah.
Okay, thank you. I hope this answers all the questions from Dr. Cheng. I don't know if you have other questions, just write or again raise your hand and I can give you the floor. I don't know if you can see the Q&A box, but apparently there was something which disturbed your answer when you were talking. So if you could repeat the answer, sorry, both, I guess, yeah, because it says answers.
Okay. So regarding the differentiation, I said regarding the net calorific value, what we do here is that we have for the different fuel type, we select an average value. So for it's not like for all biomass, but all biomass per fuel type we select, we consider a same value, like an average value of the net calorific for the net calorific. So if we have more detailed information, what can be done is that for the different fuel type, we look at the different type of fuel that the different fuel, and then we take a weighted average that can be put here. And that goes for firewood, for charcoal, and also for all the agricultural residuals and so on. Yeah. So not a same calorific value for everything, but different ones. And that's why for this for firewood, charcoal, and so on, we put it open so that the user can modify it, because we know that from one country to another, and then there is slightly differences, and it might be important to be taken into account. And we will also use this to provide estimate. And is there any option for differentiating different types of biomaterial like ethanol, charcoal, firewood? So the level of differentiation, if I can put it like that, is only at level of charcoal, firewood, and agriculture. We don't have yet for ethanol, and probably briquettes will be seen under firewood, and will be seen under firewood. So agricultural residues goes for all outputs coming from the agricultural process and so on. And I think briquettes, depending on the type of briquettes, it is coming from processor for wood. I think it will be under firewood, because at the end of the day, it will be converted. Otherwise, it will be under charcoal if it is transformed into after combustion into charcoal. Yeah.
Okay, perfect. Thank you. I hope. Sorry, can you repeat?
I don't know if that provides answer to Dr. Francis' question.
Yeah, I hope so, and I invite him to write in the chat or in the Q&A box just to give us a feedback on whether it was able, right? Okay, yes, everything. Thank you. Okay, any other question from the attendees? Okay, I don't see any question, neither raised hands. So I think that that's it for today. I don't know if you had other topics to address.
maybe something that I also wanted to show is
Yeah.
also that we provide estimates from 2020 to 2050, and as the user is playing with the different variable and show and provide targets for 2020 for different decades, and wanted to see how this is being the time series of the different variable. It can come, the user can come into the future date sheet, and for the different variable, the user can see how this is evolving over the years. So one thing that the user can do if this sheet is not that comprehensible or easily understandable, the user can, if you have a time series, you can copy and paste them here directly. For the different variable, you paste the time series based on the estimation up to 2050 for now. And then when you paste it, just come around the, you complete the analysis and directly it will take, because the compute analysis program that is here take into account this sheet where we have the progress of the different countries. And why do we have different countries? That if for the comparative analysis you select a different country, it also appears here. So for the comparative analysis, the country of interest is selected here. If it is the same country, you have Kenya, or Ethiopia, depending on the user preference. And for the comparative analysis as well, you have the trend of the different variables from 2015 to 2050. So you can modify directly here, or you set some target. So when the user sets a different target here, it's automatically completed in the linear regressions. The linear is linearized between the two targets so that we have a trend. So yeah, this also is available. The user can see the impact of the different targets in the time series here. Yeah. And I think I probably show the things. We have the different parameters. We have the whole demographic data set. Which, for instance, if the country have another estimate or more recent census, they can also changes the reports, the emissions, and dashboard. And, so that's the key point that I would like to add.
Perfect. Thank you very much, Thierry. I see that there is another question from Dr. Cheng, which asks if one user can add more data sources and years or even more fuel types into the model, or is it like a fixed model which can't be touched, let's say, can be edited?
Thank you very much, Francis, for these questions. Yeah, there is more data that can be added. For instance, if let's see, let me see, go for the so you see, for instance, this is the data that's collected from the World Bank, and you can see that for the World Bank for the database, we are yet to update this because there is more recent data up to 2020 from that one. So if, for instance, this is not in line with what the country has, they can update it for the different variables to 2020, and they can add more. So just the only issue here is just to respect how the spelling. So if I'm adding another row, I will now have to make sure that the how Kenya is written has to be there, and then I will add the year 2021 or 2022. And then I will add the different date. If I have the information for the different other data set, I will have to put them there. So it is dynamic. It can be it can be dynamical. So the more information we provided, more we can extend the data. So about the extension up to 2020 for the model, we have to make it dynamical. For now, it is fixed to 2050. Split to 2015. It's fixed up to 2050. But to make it provide up to 2020, we have to just add to make it dynamic into the program. So that one will be fixed later. We are working on it. But what's very interesting, even though it doesn't provide up to 20 out of the recent term based on the, for instance, if you feel this and you want it, the model to provide to that, you not do it now. But what we make sure to do is that when we do the projections, it will run the projection up to the latest year where we have a complete data set. So it will run the model up to the year that we have. For instance, if we are here, we have all the variables are complete, it will run it up to that before starting doing some projection. So one thing that is very interesting, even though for the historical period, we will not get up to the recent completed years beyond 2015. When it comes to the projections, it takes, first of all, what is available before starting the projection after 2020. So that's what we do. What we are extending now the model to provide up to 2020, and also to make it dynamical, such a way that when the users is adding more years and with complete data sets, it can be appearing into the historical estimation. I don't know if that Dr. Francis' question.
Thank you very much, Thierry. I think this answers his question. I don't see any answer, but I hope at least from the sound point of view, everything was fine. Okay, I see. Yes, okay, thank you.
Yeah, okay. He mentioned more fuel type. Yeah, we would love to add more fuel type, but it's about data constraint. So if we get for a particular country more information about a disaggregated data about each fuel type, we can do that. We can add more fuel type. So we appreciate if Dr. Fonsi has sources of data that are high resolution or more granulated, so we are free to adapt the model to suit its interest and so on. So we want to integrate more information into it so that we can provide as more detail as possible, so that the model can go in deep in explanations. Yeah. So these are something that we are looking for, and then if we get more data, we can deep into it.
Perfect. Thank you very much. Okay, any other question from the attendees? Again, remind you, you can write in the chat, in the Q&A box, or raise your hand through the Zoom functionality. Okay, I don't see any other question or raised hand. So if you don't have any other point to touch or to raise, I would close here the session, and really thank you for this interesting lecture. I invite the attendees, maybe first you will have available today's recording on YouTube as usual, probably by the end of today. So you can watch again today's lecture, and if you maybe missed some points and want to rewatch some specific part, I invite you to do so. On the OneDrive repository, you can find both the PDF so you have the slides, you have the description of you find the model, and you find also all the support material in order to use the model. So again, I invite you to do so. And if something doesn't work, if something isn't clear, feel free to write me, and I will also interact with Thierry so that we can support you in better using the model, understanding it, and also as Dr. Cheng was asking, also to see how you could, for example, change a bit the model in order for it to suit better what you're working on in your daily life. So could you share the OneDrive link and your email also? Okay, so this is my email. And this is the OneDrive repository. Okay, and this is the OneDrive repository. So you have both links. I will also put them on WhatsApp so that you have them, because when this session will close, you won't be able to see it again. So I also sent it on WhatsApp. Okay, so if you have any question, feel free to write us, and we will try to support you in getting into the model and also in the theoretical aspects which are behind and at the basis of the model. Okay, so thank you very much, Thierry, for today's presentation. And for the attendees, just last reminder, next Tuesday, again at 10 a.m., we will have this last webinar in which we will just, let's say, wrap up, close, and have, let's say, an overview of what was the link also between all the lectures we had till today. So, and from that, we will move to a polling session in which we will ask you some questions, some feedback, so that we can learn a bit of about what was your experience and what you suggest us also to change or to strengthen. And then we will also anticipate a bit what will be the next phase of this program, which I really hope will be in country. But it really depends on how this COVID-19 pandemic will affect our travel policies. So thank you very much, and have a nice day, and see you next week. Thank you again, Thierry.